Hello world and welcome to another video. Let's solve the problem of converting a linked list to an array. Feel free to pause the video and read through what the problem is asking for, but I find the examples more descriptive. Given a linked list, we want to convert this and return an array. In the past we solved this and here was our previous solution. We did it in time of O of n, which is good, but space of O of n squared. However, can we do better? And the answer is yes, we can actually take this down to O of n, and here's how. So first we define an empty array called values. Then we create a function. This function is what is going to end up filling our values into this empty array. We pass the head of a linked list, which in this case happens to be the A node, and also pass in our values array. Keep in mind arrays are immutable, meaning if you change an array in this function, it gets changed outside of the function also. First, as always with every recursive function, we go ahead and check the base case. Is our head currently pointing to none? If yes, just return nothing. In this case, head points to A. We append our head value, which is A, to our values array. Then we go ahead and make a recursive call, calling the field values function, but now passing head.next. This effectively moves our head from A to B. Now we're back at the top of the function again, passing head and values. Now our values array has one element in name A, and our head points to B. We check, does head point to null? No, base case doesn't get triggered. So we add that value, we append him to our values array, which in this case is B. Then we make one more recursive call, passing head.next. This effectively moves head from the B node to the C node. We check the base case again. At this point, I think you kind of get the gist. We're just going to keep doing this until we fill out the values completely. At this point, our values array is completely filled up with all the values from the linked list, and our head node points to null. So we go ahead and make our final recursive call and check. Is head currently pointing to null? In this case, yes. So we just return nothing. And here we return our values array. This eliminates the previous space complexity of O of n squared and just gives us a simple big O of n. As always, this is the function kind of like we had on the blackboard. Obviously, you're going to be given a linked list, but just in case you're not given, this is how you create one. So when you run this piece of code, you're going to have a linked list exactly like this, which is what we had on the blackboard. Then next, you call your function. And when you run this, you have an exact array. So that's it for the video, guys. I hope it was helpful, and I'll see you in the next one.